Hey guys, so this is my first video for the 2021-22 school year, and we are covering angles and parallel lines. So before I get into the angles and parallel lines, I want to remind you of the two angle pairs we learned about whenever there is just an intersection of one pair of lines. So if I have an intersection of a pair of lines, it creates four angles, right? 1, 2, 3, 4. And we called those angles vertical angles, 4 and 2, the ones that are across from each other, as well as 1 and 3. So remember, we had vertical angles, and then when they're next to each other and they form like half of a circle, we called those linear pairs. So understanding those two types of angles is going to help us whenever we're working with two sets of intersections. But remember, so when we have one intersection, the angles that are opposite from each other, like 1 and 3 and 4 and 2, are called vertical angles. Those angles are equal or congruent to each other. And then the ones that are next to each other, like 1 and 4, 2 and 3, 4 and 3, or 1 and 2, are linear pairs. Those ones are supplementary. I'm just going to abbreviate it, and that's when you have the angle plus the other angle equal to 180 degrees. If you added all four angles together, you would get the degrees of a circle, which hopefully you know is 360. So whenever we come over here to having a pair of parallel lines that are intersected by a single line, we end up with 8 angles. So we have this intersection right here, and then we have this intersection down here. So that creates 1, 2, 3, 4, 5, 6, 7, and 8 angles in total. We call this line just randomly the line that cuts through the two parallel lines. This line here is called a transversal. Trans meaning across, so it cuts across the two lines. So what's important to notice is when you have parallel lines, their incline is exactly the same. We call it their slope. So since they have the same slope, this angle and this set of degrees, regardless of what they are, is going to be the same degrees as these angles down here. Meaning whatever angle 1 is going to match exactly with angle 5. And whatever angle 2 is going to be exactly the same thing as angle 6. And the same thing with 4 and 8, as well as 3 and 7. We call those angles that are in the same place but a different circle, we call those corresponding angles. And it just means that they're in the same location, just at a different intersection. And what's important to remember about those is that they are going to be congruent. So they are congruent to each other. And if I had to set up an equation with like an expression from one of them and the expression from another, I would set one angle equal to the other angle. The other thing that might be fun to realize are all of the shapes that you can kind of make, the letters that you can make out of these. I'm going to go over those at the end, so it might be able to be something that can help you remember them. Other than corresponding angles, we have several other angle pairs in this grouping. A lot of times we like to focus on the angles that are on alternate sides of the transversal, but still on the interior of the parallel lines, so in between the parallel lines. That would be like angle 3 and angle 5, and angle 2 and angle 8. So those are our alternate interior angles. Those will also be congruent, because if you think about it, angle 2, right, is the same thing as angle 4 because those are vertical to each other. So if I go down here, angle 4 was in the same place as angle 8. It corresponded with angle 8. So 4 and 8 are the same. So if 2 is the same thing as 4, and 4 is the same thing as 8, then that must mean that angle 2 is the same thing as 8. Once we get into proofs and stuff like that, we can talk about that one in terms of the property that would allow us to prove that. So the last one that I'm going to go over in this video is going to be our two angles that are interior but on the same side of the transversal. So like 3 and 8, as well as angles 2 and 5. Those angles are going to end up being supplementary to each other, and we call those same side interior angles. So same side interior angles. And those are supplementary. Remember, supplementary means that they add up to 180 degrees. So we would be able to say that one angle plus the other angle is equal to 180 degrees. So whenever you're trying to solve any problems that are involving these types of angles, you want to remember the names, the vocabulary terms for what type of angle pair they are, but you also remember the value relationship between them, meaning that corresponding angles are congruent to each other, alternate interior angles are congruent to each other, and same side interior angles are supplementary to each other. So one option is, you could make some flashcards and try to memorize all of those. To help you in terms of memorizing them visually, let's see. I was taught by a student, his teacher that he had before me explained corresponding angles as making the letter F. So if you look, you can kind of make a letter F, and in the corners of that letter F, the little parts that come out to the side, those angles are your corresponding angles. So in the corners of your F, it would be like this and like this. And that F could be upside down or it could be reflected, but it would make a letter F if you're looking at those angles. For alternate interior angles, those ones make a Z shape. So if you look, I could go across here, down here, and across here. That would put me at angle 3 and angle 5. So for our alternate interior angles, those make our Z shape, and they're in the corners there. And it could also be a reflected Z shape, or it could look like an N or an upside down N. But if you can draw that letter and look in the corners, those angles are going to be your alternate interior angles. And then the last ones are same side interior. You could kind of make like the old font that computers used to type in, or if you're doing programming, like kind of the way the letters are written is with a real hard edge of a C. So it kind of looks like this. So we've got that one and that one. So my blue pen's running out of ink, but for my same side interior, they would kind of make like a C shape, and you would have one angle there and the other angle here. I just used two different marks to show it because those are the ones that aren't congruent. Those are the ones that are supplementary. The last way to try to help you remember the different rules if you're solving for any of these angles are going to be using a way that I like to call Enricos Way. Mainly because I didn't know about this way until last year when one of my students named Enrico showed me that this is how he was thinking about the different angle pairs. So what he would do is whenever he had a problem and they asked him to solve for a specific angle measure. So let's say they gave him an expression here for angle A and an expression here for angle B, right? So I didn't talk about the name of this pair. This is alternate exterior angles. But what he would do is instead of memorizing the specific rules, so alternate interior, corresponding, or both equal, same side interior or supplementary, alternate exterior, just like alternate interior, are also going to be congruent to each other. But instead of memorizing that, he just remembered this main idea of when we have one intersection. And he remembered that vertical angles are always congruent to each other when they're across from each other, and linear pairs, when they're adjacent next to each other and form a straight line, he remembered that those were supplementary. And what he would do is he would just take whichever angle he wanted and he would transfer it to the other intersection. So he would use the corresponding angle. If angle A is right here in this circle, then it would correspond with angle A down here in this circle. And then he could see that since these two are vertical from each other now, if there was an expression for either of these, he would simply set his two angles equal to each other. So remember, if they're vertical, we say angle equals angle. And I think that that's important, or at least a helpful way for you to do it in case you forget a rule, mainly because there is a very common set of angles that teachers like to put on tests all the time. And they're an angle pair that actually doesn't have a name, but if you use Enricos Way, you'll see how they are set up. So, and again, these are only if our if our lines are parallel to each other. A lot of times the directions will say that the lines are parallel to each other, or perhaps the directions will say solve it as if they were, or you'll see these extra arrows on the line. The extra arrows are indicating that those lines are parallel. So let's say they gave you angle A right here, and they gave you angle B right here. Now we have no name for this angle pair. We've got an exterior angle A, an interior angle B, but they're on different sides of the transversal line. So there is no vocabulary word to describe this pair. However, what Enrico would do is look at your two intersections and simply move either angle A down or angle B up. I'll move angle B up this time to its corresponding location. And now you can see that they're next to each other, that they form half of a circle, that they make a linear pair. So you would be able to set this problem up by saying that this angle plus this angle is equal to 180 degrees. So hopefully that this was helpful for you a little bit. I am either going to continue this video by attaching some examples, or more likely I will just add a link in the description bar below where you can click on that to go to another video to see some examples. But hopefully this is helpful, and I hope you have a great day.